Hey, it's Caleb. If you like this video, be sure to subscribe.
Hey, what's up everyone? Welcome back to your database design series. This video I wanted to talk a little bit more about foreign keys and a characteristic known as not null. Alright, so this keyword here might vary from relational database to relational database, but it's probably something similar to this. Not null, which we learned about null when we talked about this over here. It's basically saying the database will not accept someone not answering that column, for example. So if it's not null, you have to give that column a value every single row. So the rows are each individual entry within the table. If you have the column characteristic of not null, for every row it's going to be required that it has a value. So think of like a fax number. Does everyone have a fax machine? No, most people don't. So if I set it as not null and I didn't give it a fax number, then it would throw an error and cause problems. That's an example of how not null works. Now this is important when it comes to foreign keys because it has to do with what's known as cardinality, which we'll talk about that when we start designing databases a little more. But it's basically whether or not a relationship is required. So this is going to dictate what kind of values we can put within our table. Back to the fax machine, if we have it to where it's not null, that means every single every single row has to have a value. That also means that if someone doesn't have a value, they might not be able to put any information in this table. So by putting this restriction, you are eliminating all rows that aren't going to have a value. You're preventing them from happening. You see what I mean? Yeah. So, if the case is where you do want people who don't have fax machine numbers to be able to enter data into your table, well then you would not want to use not null as a characteristic because that's going to prevent them from doing that. Now this is important when it comes to foreign keys because if we require a relationship, we set it as not null, and that means every foreign key value for that column, every single row is going to have a relationship for that. So one of the biggest differences between primary keys and foreign keys is that primary keys are required all of the time, never changing, never null. Right? Drop my chalk. Dang it! Ah! Alright. Well, foreign keys are a little different because we can have them to where they're not required, they can be empty. Because sometimes that relationship is not there. Or they could update, like we could have a new relationship in this table, which we want to eliminate as much possible updates as possible, but sometimes that's required, and that's why we use foreign keys to keep things connected, so when things are updated, they update across the platform. Now, we don't want the primary key values to change, but we could have the foreign key references change. For example, let's say we have a table over here, alright, and we'll just have it, we'll have it be cars, okay? Or we'll just have it so the car, right? And we have two rows, and we have a car with the ID of 6 and a car with the ID of 10, right? And we have this guy over here, and we have a table for him. We'll just make it the user table. And let's say for some reason we wanted to make a connection of what car he owned. Well, he might currently own 6, right? And we don't ever want the value of 6 to change and still be talking about the same car. Let's say this car is this one over here. This is some flames. Right, and this one over here, we got a legit car. Boom, right? So these are two separate cars. 10 talks about this car, 6 talks about this car. We don't ever want it to happen to where this number gets updated, 8, or we change the primary key and it's still referring to the same exact car because then we have a changing primary key. But with foreign keys, it can change in the sense that, oh, I no longer own this car, now I own this car. So we didn't have any primary keys updated, but the foreign keys, which would be this connection right here, did update. Alright? So that kind of is a little bit of a difference between primary keys and foreign keys. Primary key values should never change. Foreign key values can change because references change. Hopefully I didn't just lose my train of thought. I think I'm going, but kind of hitting a blank here for a sec. Okay, so let me just illustrate this in a college, right? One of the important things between these tables that have a primary key and a foreign key connection to that primary key is that they have to be of the same data type, which is the type of data, whether it be int or character or date, and basically it has to have all of the same characteristics, like the collation or the character set or the storage engine. Now, the only thing that can vary is the not null characteristic. Because if we have the primary key over here, well, we know that the primary key is never null. So we always have not null for the primary key. I'll just put NN for short. The foreign key, on the other hand, it's not always required to have a connection. For example, in that previous example, we had the user table, we had this guy over here, and then we have this car table of the cars that the user owned, right? You could have one car, right? Well, he might not currently own a car, therefore we don't have a connection to this table, therefore this connection is optional or not required. Yeah, that doesn't even look like English, but close enough. So let's think of another example. If we have a college, well, we might be early in the semester where every single class, before people have registered, every single class doesn't have an instructor yet, and we're still trying to find an instructor, although we know that's the class that we want to have. So that means we have an instructors table, we'll have the instructors over here, and we have a class table. Well, a class table is going to have a foreign key pointing to the instructor for the instructor of that class. Unless the case of a many-to-many where multiple instructors can teach multiple classes, then we would need an intermediary table. But that is not the case here. If you need to learn more about that, check my relationships video. But for now, we would have a class ID and an instructor ID. Right? And then over here we have an instructor ID. As it says INS, instructor, close enough, right? Now, this is going to be a reference to this over here. Now, what kind of values is this going to accept? Let's give some examples. Let's say we have, here's a row, we have the class ID 7, the instructor ID 83, and we'll add a column, we'll make it the name of the class. We have a column and it's math. Right? And then we could have another value within here. I think I'm off screen now. Then we could have an instructor over here. His name, his ID could be 7, and his name could be Jake. Right? So this class ID is 7. Yeah, let me change this, it's going to get confusing. Let's make this 16. Alright, so this class ID is 7, and it's by an instructor of 8, which we don't actually have over here yet. So that means we either have another row or we have an error, because we never want that to happen. So let's say we have another class. Got any room? Okay, we have another class over here, and its number is 8, and it's taught by Caleb, right? So now we have an instance of a class. We got the class ID 7, the instructor ID 8, and the name math. So the instructor ID points to this instructor over here. This is the parent. I'm sorry, this is the parent. This is the child, because this is a foreign key reference to the parent. So that means this relationship is a foreign key. Now, with the not null thing, if we made it to where it's not null, if we added the characteristic not null, well, that means this row is going to have a value for the instructor ID. That means every single value for instructor ID is required. What does that get rid of? That means it's impossible to put a class in this table that does not have an instructor ID. That could cause a problem if you have a class created but you don't have an instructor yet, or if the instructor drops out and you have to find a new one. So this one might be a bad time to use not null. If we got rid of that, well, now we could have a class with a primary key but no foreign key connection. Now we have a class with the ID of 7 and it's math, and the current teacher, we don't have one. And we still have this guy over here. He's not teaching that class, but he's still in the system. Jake's still in the system. The class is still in the system. That is a good example. So for this one, not null might not be the best idea. Other examples, having not null would be a good idea because it forces that relationship to be there. Here, let me think of another quick example real quick. If we had two entities, we had a card for a credit card company. So we had the card, and then we had the person holding the card. So the person who bought the card, or was getting the card from the bank and is using it to buy their groceries and their gas, and they're ranking up thousands of dollars in debt. Well, that person would have a relationship with this card because he's the card holder. That's the card. Now, if we had a table for this, we'd probably have a card table, and we'd have a person ID, which would reference the person table, right? If we set this to not null, that means every single value or every single row within this card table is going to require a card owner. If we got rid of this, that means we could have cards in here that were outdated, that don't currently have an owner because there's no connection, we broke that owner, or new cards that haven't been given out yet. So if you want this table to just be for cards that currently have an owner, so we could have it own cards, well then we could have a not null column with the same data type as person ID. And now every single value is going to have a person ID. Does that make sense? So that's kind of the introduction of not null and how that works with foreign keys, and how sometimes you will want them to be not null and other times you want them to be nullable or not required. So yeah, that is some good stuff right there, so be sure to study all that and understand all of that because it's really important. If you have any questions, leave me a comment and I will try to get back to you. Thank you, and see you guys in the next video. Subscribe!